Okay, so this is from a grade 10 past paper. And let's look at these questions. I'm just going to plug in my pen here. Okay, so what they want you to do here is to match the letter on the left-hand side with the statements on the right. Okay, so let's look at what each of these mean, right? So A says f of x mapped to f minus x. So what that means is the x values change from positive to negative. Mm-hmm. So basically, if you, let's say you had a function like this, and you had a point over there, okay, let's say that that x value was say -1, sorry, +1. Then if you mapped it, it would go to -1, right? Which would be on this side, right? So it goes from there to there. So basically what's happening is it's flipping around about the y-axis. So it's a reflection over the y-axis. Okay, so whenever your x values go from x positive to negative, let's say that that was a 1 in here, then this would become a -1, like what I've shown here. Yeah. Right. This one here, saying f of x squared is equal to x squared, meaning if your x squared, because remember this is f of x, so if your x was x squared, then your y would become x to the 4. So that would be, your coordinate would be x squared would be your x coordinate, and your y coordinate would be x4. Okay, well we can see that that must be b.
Okay.
The next one, this f of x is basically another way of saying y, right? So this is like saying y becoming -y. So remember, when your x changed from negative to positive, it reflected about the y-axis. And the same thing here, if your y, so let's draw it here. Let's say our y value here was at a +1 over here. If it became a -1, it would go down here. Right, go from there to there. So we see that that is a reflection about your x-axis, because it's going there about your x-axis. So when your y goes from positive to negative or negative to positive, it's a reflection of the x-axis. So this one would then be C. D, let's do a different color. D, if you were to rearrange that and you took g of x to the other side, it would become -g of x. So this is basically saying f of x equals -g of x. Okay, that's not really relevant in this situation. Here we have the coordinates. Your x is x4, meaning your y would be x2. So it's similar to this one, but notice the coordinates are switched. So E was a trick question to maybe confuse you into thinking that that would have been this one. Okay, and then the last one, F, we're saying f of x minus g of x. So if we took minus g of x to the other side, would become g of x. Well, this is saying f of x equals g of x. So let's say we had a line here, and let's make our f of x green. This one, and let's make our g of x light blue. Where are they equal? They equal at this point here. Over here, that's where they equal, where they intersect. So where f of x and g of x intersect, that's essentially saying where f of x equals g of x. So that's X.
Okay.
Okay. Let's look at the next clear all drawings. Okay, so yeah, they want the domain. Very good. Okay, so let's say you're given this function. So this is we can see that this is a hyperbola, right?
Right.
So if
So
we,
it's got the two lines here. The
But-
two.
and we're plusing by 4, right? So that means your asymptote moved up because it's normally over here on the x-axis, but it's moved up. So your asymptote is at y equals 4. And your other
Right.
asymptote is always, in grade 10, is always along here, right? You've always got an asymptote of x equals 0. And your hyperbola would be drawn like that and like that, right? You do it sort of smiley face and a sad face on either side of your asymptotes. And here's your x and your y. Okay, so it's in between
Yeah.
these quadrants. If you didn't have the +4, it would be like that, right? Where the blues are. But because it's +4,
Okay.
it's shifted up by 4.
Mhm. Okay.
Not really relevant for this question. So, well, it is kind of, it's good to know what they look like. So what does your domain mean? What does domain mean? All of you?
I forgot, but I think that I actually don't know. I forgot.
Your domain is your x values. Okay. I'll tell you the way
Um,
to think of it. Domain and range is what you get asked to find. Okay, now one
Okay.
is your x values and one is your y values. What comes first in the alphabet, x or y?
Sorry?
What comes first in the alphabet, x or y?
X.
Right. And what comes first, D or R?
D.
Cool, so you can just think of dx because the domain comes first and your x comes before y. And so your range comes after d, and so x comes after, y comes after x, right? So d and x, d domain comes before range and x comes before y. So that's how I think of it. Okay.
Okay.
So your domains or your possible x values. Well, we see that we can have any value for x here, the light blue, except along the asymptote, right? See, it never touches the y-axis. You see this, the blue, the graph?
Right.
You have x values for everywhere, right? So I'll do it with a, let's say, red, right? So if I went up from the x-axis here, see I get a value here. And then I would go down and over here. See, I get x values all the way, except at x equals 0. Right? So whenever you do a hyperbola, your domain is always x is an element of real numbers, but x does not equal 0. So basically what this means is anything but 0.
Okay.
Now let's say I was asked for the range. Well, the range, if I go from the y, I get an answer. I could go along everywhere I get a value except for at y equals 4. So my range is y is an element of real numbers, but y cannot equal 4. Okay, so
Right.
in summary, whenever you have a hyperbola, your domain is always going to be this, except for the whatever the asymptote is.
Okay.
And if for the range, it's whatever the y, it's whatever the y is. It's y is an element of real numbers, but except for your y asymptote. Okay. So that's why it's very important to know your two asymptotes in a hyperbola. Okay.
Okay.
So your asymptotes are the pink line here, this y equals 4, because of this here. So this tells you your y asymptote. So this tells you your asymptote is y equals 4. And this number under here, because it's in grade 10, you don't have a value at the bottom except for x. So you know in grade 10, your asymptote is just x equals 0. Another way to think of it is you can't divide by 0. So you can't put a 0 in here because 2 divided by 0 would give you undefined on your calculator. So that's why we get this x equals 0 domain. I should have done it in yellow. You cannot divide by 0, so that's why you get x equals 0. So that's why x cannot be 0, because 2 divided by 0 would give you an undefined answer.
Okay.
Okay, we've already done question 2 now. Equations of the asymptotes are y equals 4, and what's the other one?
Y x equals x equals 0. Yeah.
Good. Yes, excellent. Okay, good. There's our two asymptotes. So as I say, when you're thinking of drawing this hyperbola, the easiest way to do it is just to do your two asymptotes, your x equals 0 here, and your y equals 4 here. And then you simply draw in your values like this. And of course, here you would have to find your x-intercept there, your y, your x-intercept by making y equals 0. Okay, so let's just see what the next question is. They do want the x-intercept.
So x equals
Okay, so
0.
X-intercept is where y is equal to what? To find your x-intercept.
0.
Good. So I'm going to do question 3 over here, just so that we can keep everything on the same page. So yes, x-intercept to make y equal 0. And so we get 0 equals 2 over x plus 4. Take the 4 across. Negative 4 is 2 over x. We can now take the 2x to the top, so we get negative 4x equals 2 to get x by itself, divide by minus 4. We get x equals negative a half.
Yeah.
Okay, so that value here, this value here is negative a half. Okay, so the coordinates are negative a half and 0. Because your y value is obviously 0, where it intercepts the x-axis. Okay. So then they ask us to calculate, to draw it. Okay, so let's just erase what we need to. Okay, so I've kind of already drawn it anyway. Okay, so what do you remember about drawing it? What do we have to find?
We need to find the
Asymptote.
gradient. No, the asymptotes.
Not for a hyperbola. So for a hyperbola, don't get confused about thinking you need to find the gradients. A hyperbola is very different to drawing it. So mark this down. Okay, let's get a strategy for doing this. So take notes. I know you've obviously got this video. Take notes of when you want the steps for drawing a hyperbola. Step one is you need your asymptotes. Okay. And remember, our asymptotes were y equals 4 and x equals 0. And that you get, let me just draw it. So you had y equals, the function was 2 over x plus 4. Okay, so you got this, gave you the asymptote of x equals 0, because you cannot divide by 0. So that's why x is 0. And then the 4, this told you your other asymptote is y equals 4. So that's step one of drawing a hyperbola. Okay, so there's our one asymptote here at y equals 4. And your other asymptote was x equals 0 over here. That's along here. Okay, happy with that?
Yes.
Now, when you have this, you can actually draw it. Okay. Technically, you could just draw it, but I want to do the second step algebraically, which is 2, is find your intercepts. Find x and y intercepts. Okay, well, x-intercept, you make y equals 0. We already did that, right? 0 equals 2 over x plus 4. So then you had 4, negative 4 equals 2 over x. And then you had negative 4x equals 2, because when you take the x to the other side, it goes to the top. And then you divide by minus 4 to get x by itself. And we got x equals negative a half. Okay, so that will make this, let's make this value negative a half. So then this value would be 1. So this value would be 1. Just to make it a bit easier to draw. So 1, negative 2, negative 3, negative 4. Okay, and then your x-intercept, you're actually going to get a 0. Because what happens when you make x 0 to find your y-intercept, right? So let's say you have to find your y-intercept. What do you do for your y-intercept? You make x equal to 0,
X
right?
equals 0.
Well, what happens if you make x 0? You get 2 over 0 plus 4. It's undefined.
Right.
Meaning you don't have a y-intercept. And that makes sense when we draw it, right? Because we go through, remember, so this was our x-intercept here. And so we draw it like this. And yeah. Okay. So there's actually only one point on this graph that it intersects, because it doesn't touch the y-axis. Okay, if they ask for one more point, all you do is you just sub in 1. Okay, and so if you subbed in 1 here, you get y equals 2 over 1, which is 2 plus 4 is 6. So 2 plus 4 is 6. So where y is 1, your this is 6. So I haven't really drawn it that nicely. It should be over there. So this point here would be 1 and 6. I'm just going to do it again. Okay. So there's your graph here. So let's see y and x here. Okay, so this is your blue is your function y equals 2 over x plus 4. Okay, you happy with
Okay.
that?
Yes.
Okay, write down the axis of symmetry that has a negative gradient. Okay, so what I'm going to do is I'm going to clear all that because we've done that. Now, let me just actually draw the axis of symmetry first. And then I'm going to show you how we can where's my fingers? Okay, your axis of this mouse. Okay. Okay, your axes of symmetry on a hyperbola look like this. They go like through there. And they always go through the middle of the asymptotes, where the asymptotes intersect. Okay, so your axis of symmetry look like this. Okay,
Right.
because the axis of symmetry is like a mirror. Don't worry too much about this. It's actually more important how to work it out from the equation. I'm going to show you a nice and simple way of doing it.
Okay.
So we're going to clear all the drawings. And we're going to go back. So remember, the question was find the axis of symmetry for these two, for this function. They want the axis of symmetry with a negative gradient. So that is the last question. So I'm going to go up to the actual equation. I'm going to show you how we would do this visually. All you do is this. What I've done in pink. Now remember, f of x is y. So you say y equals x plus 4, because that's what you see here, right? And all you
Yes.
do is for this value under the 2, you actually put plus and minus. Okay. So when you said plus x, it will be x plus 4. When you say minus x, it will be y equals minus x plus 4. And that's it. Now, which of these has a negative gradient? Number 1 or number 2?
Number 2.
Good. So this would be your answer. This would be the correct answer for 5. It would be this one here. So that's all you've got to say. Okay, so it's a visual thing. You ignore the 2 and you just write this x, but the x doesn't, you don't write it at the bottom, you write it at the top. Right? It's just a visual thing. I used to struggle with this. I had students struggle with this for ages, like plus or minus, how do we get it? How do we get it? And I just said, look, just do it visually. Don't get bogged down with like anything other than just, it's this theme here. Okay. It's that. Okay. So if you say something like f of x, and it'll get harder. So like say in matric, you're going to see something like this. Okay. It's no different. You just do that. And so it's y equals plus or minus the thing at the bottom plus 2. So when it's plus, it's then plus x plus 1 plus 2, which ends up being x plus 3. And so when you watch this in the trick, it'll be the same, and it'll be when it's negative x minus 1 plus 2. So then it'll be y equals negative x plus 1. And those are your two axes of symmetry. The one with the negative gradient has a negative value in front of the x. And we know there'll always be one with a positive and one with a negative gradient.
You're right.
Okay. Question 6 is a functions question as well. What time, just check your phone, what time did I send you the link for this video?
At 14:47.
14:47, so 30 minutes, right?
Yeah.
Okay, so we've got 10 minutes to do this. Okay, so we're given two functions. And we know this to one of the functions is a parabola and one is a straight line, right?
Straight line.
Well, we can see the parabola is the sad face parabola. That's why it's got a negative 2x squared.
It's negative 2, yeah.
That's 8, yeah. And then the straight line has one which is for negative 2x plus 4. Also with the okay, determine the coordinates of A and B. Okay, so notice that A and B are where they touch. So A and B will be, so this was the orange one here, this one here, and then the green. And so where A and B are, those are where the graphs are equal to each other, isn't it? Because that's
right, yeah.
part of the terrible drawing here. Let's try one more time. Okay, so where green equals orange. Well, we can just make green equal orange then, right? So I can just say equals negative 2x plus 4. Let's take the green over to the right-hand side because then we have positive 2x squared, which is easier to deal with. Minus 2x. When the 8 goes across, it becomes minus 8, right? So minus 8 plus 4 is minus 4. So we can just say minus 4 here. So I get this minus 4 by taking 8 away from the 4. Now to make it a little bit more simple, I divide by 2. I get x squared minus 2x minus 2. And so I get, when I factorize this, I should get, like, have I written them down right? Minus 2x. X squared I feel like that we need to get a we have to get a That's the mistake. That's the mistake. Minus 2 divided by 2 is minus 1. Sorry, so this here is minus x. There we go. Okay, we get minus 2 and it's plus 1. Okay, so it's x equals 2 and x equals minus 1, right? So this value here, this one will be the 2. And
Yeah.
this one here, this will be the minus 1. And to get the y value, I just sub into one of them, right? So let me sub into the negative 2x plus 4, right? So negative 2 times negative 1 plus 4 is 2, right? That's this one here, 2. And then when I sub in 2, negative 2 times 4, I get minus 4 plus 4, 0. Well, that makes sense for this on the x-axis. So it happens, so y is 0. Okay. Okay, and then finally, give the values. Give the values for which f of x is greater than g of x. Where is f of x bigger than g of x? Okay, so here again it's visual. Okay, so green is our f of x. So where is f of x greater? So where is green bigger than orange? That's basically what they're asking. So if I highlight it, where's green bigger than orange? It's all over here, right? This here is where green is bigger than orange. Okay, so it's from here to here. So it's in between these 2 points. So we know our x value here. So it's where x would be then bigger than the minus 1. So it wants to eat the x because it's bigger. Remember, this guy's greedy. And then the 2, it's going to be less than 2, right? So it's less than 2. The crocodile will want to eat the 2 if it's less than 2, because the crocodile always wants the bigger value. Okay, so this would be our answer for B. Okay, for what values of x is f of x greater than g of x? So where is the parabola bigger than the straight line? Are you happy with that?
Kind of.
Okay. Okay, you're only kind of happy. So remember, your f of x is the parabola here. Okay, like that.
Yeah.
And your g of x is a straight line here. So when they ask, okay, so f of x here, right? And g of x is the straight line. Where is the parabola above the straight line? Yeah, right?
Yes.
Over here. I'm going to highlight it. It's bigger over here. Are you happy with that? Are you happy with that first? Can you see that the parabola is above the straight line? Where I've highlighted.
Yes, I can.
Okay. So that is technically where f of x is greater than g of x, because it's higher. So all we need to do is find the x values that this bit represents. So that's what I've done here, right? I've done that. So that is where it's bigger. And then you go down and you find those values. And so it's these values where they're equal. So that is why in question B we were asked where they equal. Because do you see that this value here is -1? Are you happy? The x value here is -1.
Yes.
X value here is 2. And so between those two values is where f of x is greater than g of x. And so this is our algebraic way of saying this, okay? Let's look at it a different way. Where is orange bigger than green?
After the point where they meet,
Over here and here, right?
yeah.
So if they asked where g of x is greater than f of x, then our answer would be where x is less than this -1 value here, because it was -1 here, and x is greater than 2. So it will be the 2 on the either side, right? So it will be that way and that way. But we found that the f of x was greater than the g of x in between these two values over here. So this here is how we write. This is how we write in between 2 and -1, okay? X is in between -2 and 2. -1 and 2, sorry. Let's just go back. Yeah. Okay. Okay, I'm going to end it there. And then what I'll do is you can rewatch the video and see if it makes sense the second time around. Sometimes it's easier to watch again and see. And then, yeah, if you've got any questions, just feel free to ask.
Okay.
I'm going to end it there in case, because I might be able to start again if I end it early.